astronomers have observed an explosion 180 million light-years away that challenges our current understanding of explosions in space, which appeared much shallower than ever thought possible. The explosion observed was a bright Fast Blue Optical Transient, FBOT, an extremely rare class of explosion, much rarer than other explosions such as supernovae. The first bright FBOT was discovered in 2018 and was nicknamed Cal. Explosions from stars in the universe are almost always spherical, since the stars themselves are spherical. However, this explosion, which took place 180 million light-years away, is the most aspheric ever seen in space, with a shape like a disk emerging a few days after its discovery. This segment of the explosion may have come from material that the star shed just before it exploded. Dr. Justin Maund, lead author of the study from the University of Sheffield's Institute of Physics and Astronomy, said, "Very little is known about FBOT explosions. They just don't behave like exploding stars should. They are too bright and are evolving towards fast. Put simply, they are weird, and this new observation makes them even weirder." Hopefully this new discovery will help us shed a little more light on them. It was never thought explosions could be so aspheric. There are a few possible explanations for this. The stars involved could have created a disk just before they died, or it could be failed supernovae, in which the star's core collapses into a black hole or neutron star, which then eats up the rest of the star. What we now know for certain is that the recorded degrees of asymmetry are a key element in understanding these mysterious explosions and challenging our preconceptions about how stars in the universe might explode. Scientists made the discovery after spotting a flash of polarized light completely by accident. They were able to measure the polarization of the blast, with the astronomical equivalent of a pair of Polaroid sunglasses, with the Liverpool Telescope, owned by Liverpool John Moores University, on La Palma. By measuring the polarization, it allowed them to measure the shape of the explosion, effectively seeing something the size of our solar system but in a galaxy 180 million light-years away. They were then able to use the data to reconstruct the 3D shape of the explosion, and were able to map the edges of the blast, allowing them to see just how flat it was. The Liverpool Telescope's mirror is only 2.0 m in diameter, but by examining polarization, astronomers were able to reconstruct the shape of the explosion as if the telescope were about 750 kilometers in diameter. In conclusion, this Fast Blue Optical Transient explosion 180 million light-years away challenges current understanding of how stars explode, as its shape was aspheric like a disk. Using polarization measurements, scientists reconstructed the explosion's 3D shape and mapped its edges, offering insight into this unusual phenomenon. Ongoing monitoring of the universe is vital in uncovering such unexpected phenomena and improving our understanding of the cosmos.